friends. In last few lectures of professional practices course, we have discussed about various topics like estimation, types of estimates, a role of estimator, good qualities of estimator, valuation, contracts, type of contracts, then essentials of legally valid contract, measurement sheet, abstract sheet for computation of volume. Now, in this session, we are moving further to finding out various areas and volume for different types of geometrical shape, which is necessary for finding out the area and volume for different types of structures like dam, spillways, canals, etc. Myself, R. V. Zugdar, Assistant Professor in Civil Engineering Department, Sharad Institute of Technology, College of Engineering. Now, for any kind of a structure, we must know first its area and volume for computing the earthwork in embankment as well as cutting and filling. On the primary object of land survey, one of the primary object of land surveying and quantity surveying is to determine the area of surveyed land and to determine the quantities of earthwork. The computation of area is very essential to determine the catchment area of river, dam and reservoir. It's also important for planning and management of any engineering project. For initial reports, the estimates low precision methods can be used, but for precise or high level of accuracy, it is required to employ the professional engineer or land surveyor for the same. Since these projects are of high priority, like dam, culvert, spillways, therefore it is necessary to find out the accurate volume of water to be stored and volume of embankment and is needed for finding out the cost of project. Therefore, generally it is calculated or find out by accurate means of method. The area is expressed in feet square, meter square, kilometer square, acres, hectares, etc. Whereas volume is expressed in centimeter cube, meter cube, feet cube, kilometer cube, etc. First of all, we must know the simple thing of unit conversion because unit conversion is important for calculating or computing the various volumes, that is water storage capacity or cutting and filling in desired units. The general unit conversions are 1 meter is equal to 3.28 feet, 1 square meter is equal to 10.76 square feet, 1 square kilometer is equal to 10 raised to square meters. 1 hectare is equal to 1000 square meters, which is also equal to 2.47 acres. 1 acre is equal to 0.40 hectares. 1 square mile is equal to 640 acres. 1 kilometer is equal to 1000 meters. Now, by this unit conversion, we can directly convert the desired volume in desired units. Methods to compute area. The method of computation of area depends on the shape of the boundary of surveyed area and accuracy required. If the plan is bounded by straight boundaries, it can be tackled by subdividing the total area into simple geometrical shapes like triangle, rectangle, trapezoid, etc. And the area of figure are computed from the dimensions. If the boundaries are irregular, they are replaced by short straight boundaries and the area is computed using approximate method. While if the boundaries are very irregular, the area can be determined by using planimeter. Either it is mechanical planimeter or digital planimeter. Computation of area from field notes. During the survey work, the whole area is divided into some specific geometrical shapes like square, rectangular, triangular, etc. And then the total area can be computed directly. The chain line is running approximately in the center of area to be calculated. Then, by using the cross staff and optical square, mark perpendicular offset on the chain line. Offset on the chain line are measured when chainage, and then area is calculated by forming regular geometrical shapes in the form of triangle, rectangle, etc. The surveyed area may be calculated from plotted plan by following rules, that is mid ordinate rule, average ordinate rule, trapezoidal rule, or Simpson's one third rule. Mid ordinate rule. The method is used with the assumption that the boundaries between the edges of the ordinates are straight lines. The baseline is divided into number of divisions and the ordinates are measured at the midpoints of each division. So, as shown in figure, the O1, O2, O3, O4 are the ordinates at the center points or midpoints and endpoints of the given chain line, in which D is the distance between two cross-sectional areas and L is total length of chainage. The area is calculated from formula for midsection is area is equal to common distance into sum of mid ordinates, that is h1 into d plus h2 into d plus dot 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 h last section height into d, where d is putting common d area is equal to d into h1 plus h2 plus h of or height of last cross sectional area, where n is number of divisions, d is common distance between ordinates, and h1 h2 hn up to hn are mid ordinates. Average ordinate rule. This rule also assumes that the boundaries between the edges of the ordinates are straight lines. The offset are measured to each of the points of division of the baseline. The area is given by following equation. Area is equal to average ordinate into length of the baseline, which is equal to O1 plus O2 plus O3 dot 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 up to last section upon n plus 1 into total length of chainage, which is equal to L upon n plus 1 into summation of all ordinates. The next method is trapezoidal rule. This rule is based on assumption that the figures are trapezoids. The rule is more accurate than previous two rules, which are approximate versions of the trapezoidal rule. The following figure shows the total chainage of L and ordinates having O1, O2, O3 at particular sections and the distance D between two sections. The area of the first trapezoid is given by delta 1 or A1 is equal to O1 plus O2 upon 2 into D. Similarly, the area of second trapezoid is given by delta 2 is equal to O2 plus O3 upon 2 into D. So the total area of the figure is given by area is equal to O1 plus O2 upon 2 plus D plus O2 plus O3 divided by 2 into D up to last section of the chainage. The total area is then calculated by O1 plus 2 times O2 plus 2 times O3 plus 2 times O4 plus On into d by 2. Now it is given in words that the total area is equal to common distance divided by 2 into first ordinate plus last ordinate plus 2 times sum of all other ordinates. Simpson's one-third rule is one of the method for finding out the areas. This rule assumes that the short length of boundary between the ordinates are parabolic arcs. So this rule is sometimes called as parabolic rule. This method is more useful when the boundary line departs considerably from straight line. The following figure shows the setup of the lines in the survey, where d is the distance between two ordinates and the parabolic shape or curve shows the total straight line distance between the two sections. Here O1, O2, O3 are the consecutive ordinates and D is common distance between the ordinates. Now area of AF2DC, that is area of AFDC plus area of segment F2DEF, that is area of trapezium as shown in the figure, that is the area in curve shape and straight line, and the area of base figure. The area of segment and trapezium can be calculated by two-third area of parallelogram F13D, that is two-third of E2 into 2 times D, and the total area is calculated by two-third of O2 minus O1 plus O3 upon 2 into 2 times D. So the area between the first two divisions can be calculated by the formula delta 1 is equal to d by 3 O1 plus 4 times O2 plus O3. Similarly, the area between next two divisions can be calculated by delta 2 is equal to d by 3 O1 plus On plus 4 times O2 plus O4 plus 2 times O3 plus O5, that is odd ordinates of the chainage. Now common distance by 3 into first ordinate plus last ordinate plus 4 times sum of even ordinates plus 2 times sum of all odd ordinates will give the area by this rule of parabolic shape or by Simpson's rules of one third formula. Now, in this session, we have discussed about various rules and formulae for finding out the areas. The following examples are necessary to study for detailed knowledge. The following offset were taken from chain line to the irregular boundary line at an interval of 15 meter, 2 meter, 2.40, 3.10, 2.60, 3.70, 4.20, 3.90. Compute the area between chain line, the boundary line, and end offset by the mid ordinate rule, the average ordinate rule, the trapezoidal rule, and Simpson's rule. The following perpendicular offsets taken from the chain line to irregular boundary. Chainage is 0, 10, 15, 25, 40, 50, 55, and offsets are 10.1, 12.1, 5, 14.5, 13.6, 12.2, 9.8, and 11.9. Now, computation of volume by trapezoidal rule and prismoidal rule are solved in further slides. By trapezoidal rule, volume can be calculated by V is equal to d by 2 into A1 plus An plus 2 times A2 plus A3 plus dot 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 up to last section An minus 1. The common distance divided by 2 into first section of area plus last section area plus 2 times sum of area of other sections. Putting all values, we can get the total volume of the given data by trapezoidal rule. Similarly, by Prismodal formula, we can get the volume by V is equal to d by 3 into a1 plus an plus 4 times a2 plus a4 plus dot 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 an minus 1 plus 2 times odd areas, that is a3 plus a5 plus an minus 2. Limitations of Prismodal formula are that Prismodal formula is applicable when there are odd number of sections. If the number of sections are even, the section is treated separately and area is calculated according to trapezoidal rule. Now,